All right, these are the next two graphs. So this is our h of x function, and this is our k of x function. So that's what we're looking at, and we want to find out anywhere where this function is smaller than this function. So highlighting, these are all of the points where it's smaller. So points for x that that's true for would be not 2, because at 2 they're actually equal, but at 1 this is smaller, and at 0 that's smaller, -1 that's smaller, -3 that's smaller, -5, no, 1, 2, 3, 4, 5, at -5 this one is now bigger than that. So none of those would work, and none of those would work. So these are a bunch of different ones that would. Specifically, we want all the ones now that, oh wait, we've changed it. So in general, what values of where is this greater than the line? So now we're saying all of these parts, I'm going to change colors. All of those parts are greater than the line, and all of those parts are greater than the line. So how would I describe that? I want all of these x's, so x is greater than or equal to 2, and I also want all of, well, or either one is fine. I suppose or is better. Or these guys over here, so all the x's that are here or less, which mean less than or equal to -3. So these here will be all the ones where this function is bigger than the other function. So it says here, choose one value for x where this minus this is equal to 0. So first of all, we need to recognize that when you're going to equal 0. You're going to equal 0 when these two things are equal to each other. So really what we're trying to do is to figure out one value where both the h of x and the k of x are going to give you the same answer. So if I plug in 2, so if I have h of 2 minus k of 2, that means my output is 2 minus 2 is 0. I also have this option here, that h of -3 minus k of -3, this is equal to 1, 2, 3, 4, 5, 6, 7. So that is 7 minus 7 is equal to 0. So again, at this spot and at this spot, it's equal to 0. Now, let's look at here. Here, this is saying, wait a second. When is it that this is bigger than this? Because if you're going to subtract them and get something that's positive, that means the h of k is bigger. Well, we've already looked at all these regions where it's bigger. So let's pick a nice pretty one right here. This h of 3 is equal to 1, 2, 3, 4, 5, 6, 7. And k at that same spot is really equal to 1. So 7 minus 1 equals 6. What does this mean in real words? So 3 would be our x value that worked for. There's lots of other ones that you could choose. But in real words, it means that when is something bigger minus something smaller greater than 0. So in other words, when is it the answer positive? It says create a new function called g of x such that this one here is always greater than this one here. So this is k of x, which is not always, but I want a function that is always smaller than this. In other words, I don't ever want to be hanging out up here, because then those are sometimes larger than this little section down here. Any function that I have down here, so any y-intercept down here, positive, negative slopes, any of these things here will always be less than every single part on here. So we want to figure out, again, pick one your own, such that this will really give you smaller than that particular graph.